Hey everyone, welcome back to Fully Defined. My name's Chris, and in this video, I'm going to take you through a CSWA practice exam. CSWA stands for a Certified SolidWorks Associate, and that certification is the entry level into the SolidWorks Mechanical Design Training Certification Program. I should be clear up front, I do not have the CSWA. In fact, on my journey into certifications, I skipped it. I went straight for the SolidWorks Professional sometime around 12 years ago. I am a certified SolidWorks expert, which is just about the highest level you can achieve. What I'm doing is researching where people need the most help and where the most people need the most help. And it seems like there's a lot of designers and engineers out there that are looking for help to get their CSWA. In this video, I'm not going to go through everything like downloading and setting up the tester software, okay, or talking in detail about all the different certifications. Purely looking at the practice exam and maybe some things that you can do to practice if you're having any particular issues with any elements of that exam. Also, in the description below, I'll link you to some other reasonable quality videos taking you through the same exam or other examples of it. All of these are free. YouTube is a great resource for learning. Let's get into it. So you can see from the SolidWorks website, from their certifications, there's a link there to Mechanical Design, CSWA, and that takes you through a little bit of information about the exam, what might be included in the challenges there, and a sample exam at the bottom. And that sample exam is what I've got open here on the left of the screen. When you download that sample exam and open it up, you need to, with any zip file, you need to make sure you extract the files to another folder before you're trying to open them in SolidWorks. I've done that here, and you can see there's three part files and the sample exam PDF. So let's go into that PDF and let's run through this practice. Highly recommend for anyone attempting these exams, you have two screens, or if you don't have two screens, at least set up your one singular screen so you can have the testing client, or in this case, the sample exam on one side and your SolidWorks software on the other side. Now, I'm not going to read you through the entire PDF. We're going to skip through here and go to the important stuff, which is the first questions, which start you off for your exam. So the practice exam starts here with a couple of questions on drafting. Now, I'll get my head out of the way so we can see the answers. Question 1, drafting competencies. To create drawing view B, and that's this one on the right, is it necessary to sketch a spline as shown? This spline is this organic shape on the left on drawing view A, and insert which SolidWorks view type. So what it's asking is, once you draw this spline on that drawing view, which button are you going to press to get drawing view B? Section, crop, projected, or isometric? Now the answer is crop. A section view, well, that doesn't work with a spline. A projected view is another angle of that view. Same thing with isometric. Crop is where it actually cuts away everything outside of the shape that you've sketched. So B is the correct answer. Now question 2 goes over these 2 pages. To create drawing view B, and what they're indicating here is this section in the top right corner. It is necessary to sketch a spline as shown on drawing view A, the spline in that same section in the corner, and insert which SolidWorks view type. Is it an aligned section view, detail, broken out section, or section? This example, where it is showing only a partial section of your object, is related to a broken out section view. So the answer for this question 2 is C. Those 2 questions out of the way, we can get into the tricky stuff, and that is the part modeling. So our first step, well, the first thing you'll want to do in this exam is to recreate the model that you can see on screen. And these will be used to answer questions 3 to 4. Okay, so we can see all of the information here. And it does give us some other information over the page for dimensions A, B, and C, and giving us certain numbers for those. And then the first answer is multiple choice. So in the exam, you'll have 4 options, and you need to find the option closest to the measurement, the mass value that you can find after completing the model. Not going to focus on any of that first. First job is to actually just sketch this model correctly. Okay. Now, to do this exam and to do this task, you should have already spent a number of hours learning the software. I would recommend it's between 30 and 50 hours. That would be equivalent to having spent one semester of three hours a week across 12 classes. That's 36 hours plus homework. Okay, if you're able to do that, then you should get most of the way there to be able to creating this kind of geometry without too much difficulty. Okay, now, important step. Unit system is mmgs, so it must be in millimeters. It's in the bottom right of the screen. If you're in inches or anything else, just make sure you click on that arrow and click to mmgs so you're in the right units. All right, so let's start here with the part modeling, part 2. Now, what we're going to do is create this model. Now, if you've already spent a semester, a couple of weeks at least learning the software, you should by this stage know how to sketch, dimension, and create extrudes and cuts so that you could create a shape like this. If you're not yet at that point, I'd recommend you check out some of the other tutorials and resources available online to get that confidence up. Link in description below. What we can see from these 3 drawing views is a bunch of dimensions, some information about relations, such as the tangency relation, radiuses. Also, we can see the letter A, B, and C. A, B, and C refer to these 3 measurements over the page. Here we can also see the unit system, millimeters. And A, B, and C, we're going to use those as global variables, which means we're going to have them controlled by a value that we input and we can change, because the way this exam is set up is that A, B, and C equals these numbers to start. But then once you've answered the first question, the later questions ask you to change those numbers. Now, you can do this without global variables. I should make that clear as well. But it's a pretty easy skill to put in and to learn for your exam, which can make things a little bit quicker. So I'm going to show you how to do that here. We're going to right click on our part at the top of the feature tree. We're going to click on Hidden Tree Items, Equations, and Manage Equations. And here we're going to add A, and we're going to add the value, which is the number we can see here. A is going to equal a number, which is 81. And then we're going to add another global variable, B. B will equal 57. And then C is going to be 43. Press OK. And now we have our equations. We can see A, B, and C. Now there is an alternative to doing that. If you're unable to do that, I'll show you how to do it the other way as well. Now that we've got those, let's go ahead and complete our sketch. And we're going to do that on the front plane, and we're going to use this circle as the center of that circle is our origin. So we can put that in as our very first sketch. I have a setting on for my sketches, which means I can draw and input a dimension without using the dimension tool. To get to that option, we go to Tools, Options, Sketch, adding this option here, Enable on-screen numeric input on entity creation. Tick that one on, and also tick on the second one, and that will allow you to use that setting as we go. So we create a rectangle, and our rectangle is going to have the outside shape of our part. So this is going to be our bounding box. And I'm going to dimension it from the center point of my circle, 14 and 14, because what I'm trying to do here is get everything fully defined, which means all my blue lines that can move around, I want them to be black. All right, so A. Now this is where, if you don't know how to do global variables, you can click the dimensional line, you can drop it, and you can input the number for A, which is 81. We have done our global variable, so here we're going to press equals, go to global variables, and select A, and then press OK. And we should see the equation sign next to that number that shows it's linking to that equation. I'm going to do same for the side, which is going to become B. All right, and now I have a bounding box of the shape that I'm sketching. Okay, at this point, just having a look at the sketch, I've actually put in an incorrect dimension. That's 14 here. I can delete it or I can change it. To change it, what we need to work out is actually what I need to change it to. And what we can see from this sketch here, I'm just going to move that. Okay. I've used this number 14 here, but that's wrong. I'm actually coming from this line across the bottom, this one here. So I need 14 plus 19 to get that position. So I'm going to go here 14. I'm going to go plus 19, enter, and that's going to move it up to the correct height. Okay. If you enter a wrong dimension, you do not need to delete the dimension. You just need to be able to change it. Okay. Now that position looks much better. Let's draw our shape. So I'm going to draw straight line down, line across, straight line. Now to get a little radius, I'm going to bring my line out, go back in and curve down to get a radius. And then again, back in, down to get an arc. Line, line, line. I'm going to stop here and press escape. I can't get that curve. Okay. So I'm going to continue on from the side view. Sorry, I'm going to continue on from the left side, draw across, down, and then my arc there to finish off. I just need to change that shape. Okay, and now that's our complete shape. What we need to do now is dimension it. But having set up the A and B dimensions already, it means that we're pretty close with the geometry. It shouldn't change too much as we're adding these dimensions. Let's start from the top right-hand corner. We're going to add a 45-degree angle for this one. And we're going to add a 5mm dimension here. And all we're doing as I'm dimensioning is going through and ticking off one by one these dimensions. Okay, so you don't have to physically mark them off, but that is a tool you can use if you find that you get to the end and you're not sure which dimensions you're missing. But there's a simpler tool that might be able to help. Okay, it's 29. Now see when I do that and this section here crosses over itself, well, I just need to grab this line and move it to the side. Okay, and then I can keep going. Turn this one, 19, 5, 29. Now the center point here of that 29, that center point is on that line. So in our sketch, I can grab the center point, hold control of my keyboard, hit the line, and make it coincident. All right, this one is 7. This is also 45. 8. We do not have this dimension yet. Yes, we do. It is, say, the 19 here, this one. So it's 19 to that center point. So from here to here, 19. Okay, let's continue. 45 at the top, click across to the side, that's 7. We have a 10-degree angle for this slight section, 14mm dimension to that point, 32mm from here to here, and then a 19 radius for that curve, and then lastly 29 to this point. And then we have a fully defined sketch, and I can see that at the bottom of my screen down here, fully defined. Now if you don't have it fully defined, well, cross-check what you see on your screen versus what you see on my screen. If there's a dimension missing, if there's an area that's blue, okay, like this, see this section's all blue, well, here's my tip. Click and drag one of the blue points and move it around and see what happens. And that will indicate to you what dimension is needed. All right. Now with that done, we can extrude it, and we want to extrude it by the distance C. Let's extrude it mid-plane, and let's hit for distance 1 equals global variables C. Okay. Okay. And that bit is done. So we've completed the model. It's a good idea at this point to save. So hit the save key, find somewhere to save it, and give it a name, just so you don't lose your work. Right, let's continue on. So now we've done the model, we need to make sure that we've got all of our unit system and materials correctly assigned. So our unit system, we should already be in millimeters. Correct. Okay. The material we need to apply, ARI SI 1020 steel. To apply material, right-click on material, go edit material, and we're looking for 1020 steel, and we're looking for that 1020 steel with a density of 0.0079 grams per cubic millimeter. We can see here under the density of this steel, 7,900 kilograms a meter cubed. 7,900 and 0.0079, these are the same. Now, what's very important, and I saw this in one of the other tutorials, is like this next material down, you can see the mass density, 7870. That's different, okay? And that will cause you to get an incorrect answer. So make sure you're selecting the right material, press apply, close. You should see the material here in your feature tree, and now that material is correct. So at this point, we should be able to find the answer. To find the answer, we're going to go to evaluate, mass properties. We're going to look here on our screen, and we're looking for mass And my mass is 939.54, and that is matching answer D. So our first answer, well, we're going to assume that's correct. That's the correct answer. Spot on to 2 decimal places. Okay, step 1 done. Let's keep going. Now we're going to modify the tool. Everything stays the same except we're modifying these parameters, A, B, and C. And this is where you can just change your equations. So for anyone that's set up the equations with global variables, right-click on equations, click Manage Equations, change A to 84, change B to 59, and change C to 45. Okay. Now, hit Reload or Rebuild on your file, or Control B, and make sure it's updated. And to double check, let's click on our sketch, and let's see if those numbers have updated. 84, 59, and C, 45. They're all correct. Now, at this point, we no longer have multiple choice. We have to input an answer. So what is the overall mass? Our overall mass, we would say, is 1032.32. I'm going to write that in a comment, and showing out of the screen. Here is my comment. Answer 2, what did I say it was? 1032, okay. 1032.32, okay. 1032.32, all right. That answer's in there. Next question. Now we started to do some additional changes. These images are to be used to answer question 5. Now, before you do the changes, my suggestion is to look through all of the information for that question and then come back and do the process of any more changes. So it's telling us here, in the system's the same, materials the same, density is the same. Use the part code in the previous question and modify it by removing material and also by changing the following parameters. So let's change those again. Manage equations, 86, 58, 44. All right, change those 3. Now, let's change the geometry. So, my recommendation here, have a look at the standard views and see what matches the views that you're given in that drawing. Now, this view is view number 2. If I want to save this view, I can hit spacebar and I can press new view and just put in 2. Now, this one to the left, it's about this angle here. I just did that by hitting some arrow keys. All right, this could be view number 1, and then this could be view number 3. We can ignore the color difference. There's nothing to worry about there. Now, from view number 1, if I'm comparing to the view that's over on this screen, I can see that it has a cutout area, and I'll show you what I mean. This section here, the cutout material, and they also cut material here. Okay, so we want to cut that, we want to cut this. Those are the things that we want to cut. I think that the other thing that I can see is there's another hole here. This hole goes all the way through. So we're going to add that hole too. They're the 2 main things I can see that we need to do. There may be more. Let's go and have a look at the dimensions. This view is a top view. Let's go to our top view and we can see what it looks like. And we have a dimension that is 19 on the left, and then we have a 12 and a 24 on the right. And then from the front view, we can see where that hole is, 11, and it's 14 and 14 from the top and sides. Let's add the hole, and we're going to add it by changing the original sketch, placing that hole, dimensioning it, so using my 14 from the top and the side, and then hitting accept on the sketch. Now that hole is done. So I don't have to do anything else with that hole. Let's continue to look at these views, and then I can see on this section view MM. Section view MM is important because that is this view here, with that line running through the middle. So we can see there's a hole, a circular cut. It's got a radius to it with a 41 mil radius, and that is offset 12 millimeters from that outside. So here's what we're going to do. On our front plane, we're going to do a new sketch, and we're going to draw a circle here with a radius of 41. Now, when we're drawing circles, we get a diameter. So what we need to do, you can either work out the mass in your head. 41 times 2 is 82. Put that in. Alternatively, you can put in 41 times 2 if you can't work out the maths yourself. You'll get the same result, 82 diameter. To be sure, I can press liters. I can change that to a radius. It will show me radius 41. I need to now dimension those other elements. So the center point is in line with this edge. So I'm going to make that coincident. And then the bottom arc here crosses over this edge. So I just do it I selected a point, I put a sketch point on my circle, and I move that point to be coincident with this edge. I can now dimension from that point to this top edge to put in that 36 millimeter dimension. Now I've got my circle. I don't need to do anything fancy. I don't need to trim anything away. It's just going to be a cut. And so if I go back to this top view, I go here, now I can do a extruded cut. And in this direction, I want to go offset from surface 12 millimeters. And then in the opposite direction, we will have to work out some maths because it does not give us the number. It tells us 24 millimeters, but we can work that out, can't we? Now, the way we can work that out is to look at the numbers that we're given. C is 44. So when I'm looking here and I have C equals 44, then I have 12, 24. So 44 minus those two is what's going to be X. And if I do my maths with my calculator, 44 minus 24 minus 12 equals 8. So X equals 8. So now I can do the same thing with direction number 2, but offset from surface. That's going to be 8. Hit enter, and we've got that shape done. Okay, very nice. Now that's the first part. The second cut is that 19 one. Now, is there any other information for 19? The tricky thing that they've done in these drawings is that these two views you see on screen aren't to scale, okay? They're not, it's not like a projected view from one to the other. And the way I can tell that is because look where this line is here, okay? And look where this line is here. If this was a front view and then a top view, those outside edges would be aligned, all right? Now, why this is important is because this dimension 52 at the bottom, okay, that gives us this line, and that line is actually the one that we need here. So what we can say is from this top view, this box that we're going to cut through is 19 high from that edge, and it's 52 from this edge. All right, we can see that down here. So let's do that. We'll go to our top plane, do a sketch, draw a rectangle from the outside point. Now I'm going to make it 19 by 52. Sorry, it's not 19 by 52. It's 19, and then we're going to add a dimension from the outside edge that is 52, like that. Then we're going to do an extruded cut through all, and we're going to go through all both directions. And there we go. Now, let's do a check. Before we go and do our answer, we want to check each of these views to see if we've got it right. What I'm going to suggest here is we go to view number 1, and we see, does this look like the left image? Yes. View number 2, this also looks like that next image. It doesn't need to be exactly perfect, but it should be close enough. And the last one, view number 3, hole, bit of a curve, bit of a cut. And now here we've identified, or I have at least, something that we've missed. And this is why we do these checks. In this section, on the third view, there's a cutaway. We haven't done that, all right? So we have to work out where that information is and put that into our model. So we can see it here on this next bottom view. All right, so we're going to go to the outside face. I'm going to draw a sketch, and it is 19 high, and we're going to go all the way to this edge and all the way to the bottom. Now, I've just made that collinear, but I'm going to check that that's 19, and that is, okay? So we've got 19 all the way across there. And then I believe that the view that we're looking for to show that cut is this side view, which is here. You can see this one, and that says that the cut goes across 19. So we're going to do an extruded cut, blind, 19, all right. And now all our views should be matching what we can see. That looks much better. Let's save. Let's go to see what the answer is they're asking us for, and that is what is the overall mass? This is step 3. We're going to go to evaluate mass properties. The mass is 628. I'm going to copy that. I'm going to go to my comments and add another comment here. Answer 3, 628 grams. Okay, let's continue. Not much time to waste. Now, last question, I think, in the modeling is this question 3. Okay, for this part. Now, we are moving quick through this tutorial, but in the exam, you have 3 hours. It's plenty of time. All right. Now, question 6. we're going to be cutting away some material. You can see that here, okay? And you can see that with this 1 millimeter wall thickness. So we're going to be cutting away. We get a section view here showing us how that looks, how that deep that is. That's going 12 millimeters. So step 4, modify the part by adding a pocket. Only one pocket on one side is to be added. It's not symmetrical. We're not changing any other dimensions. We're just adding the pocket. You can. Let's go ahead and do it. We will start on this side view, and we're going to draw this 1 millimeter wall. To do that, we're going to create a sketch. We're going to use offset. I'm going to hit 1 millimeter and then reverse, so it's on the inside face. Now, the section view that you can see shows us that the cut, I'll replicate the section view. It's essentially this view here. The cut is going to 1 millimeter away from this face here, this face. So the first cut we're going to do, I'm going to go extruded cut, offset from surface, 1 millimeter. Now, why I'm saying 1 millimeter, even though it's not showing us in dimension, is because it's said typical, 1 typical. And that would mean that that wall thickness is 1 around those sections. So I'm going to assume that. We'll continue. Okay. So that is the first cut. The second cut goes deeper, and that's where we get this 12 from. And that is here on this view, where we need to cut out all this material in here, up to 12 millimeters from that wall. So to do this one, we're going to do another sketch on that face and convert the edges. I'm then going to use this edge here, and I'm going to offset this one 1 millimeter. And then I'm going to do an extruded cut. I'm going to select this contour. I'm going to go offset from surface 12. I'm going to select this outside face. Press OK. Now, just for comparison's sake, let's put a color on and let's save, and let's do a section view to see how we compare. And even with my section view here, I'm going to hit keep cap color so you can see our thickness. And here we are matching that view, that section view. Are we matching the 3D view, which is view number 2? Synced? I say yes. I think that looks very close. Okay, let's assume it's correct. Let's go to our mass properties, and we can see our mass is 432.58. So I'm going to go edit my comment, answer 4. There we go, 432. And we have completed our modeling challenge. So I'm going to save this, and we'll come back to the answer after we've completed the second part of the exam, which is assemblies. Now, before we do it, before we create the assembly, again, in your exam, go through the questions, all of it, before you start. All right, so you can see what's required of you. Now, there's the answer key. We won't look at that just yet. I've only got 2 pages here. This image is used for answers questions 7 and 8. It's an assembly. You can see some angles and some numbers. Build the assembly, download the zip file and open it. We've done that. Save the parts, import them, create the assembly using the following conditions. Pins are concentric. Pin end faces are coincident. Units are millimeters. Assembly origin is shown. And then set angles of A, B, and C to 25, 125, and 130. Then we need to work out what is the center of mass of the assembly. Okay, let's do it. I'm going to create a new assembly. I'm going to go to my folder, click my 3 parts, and drag them in. I'm going to set don't show again on this and keep SolidWorks textures only. And I'm going to go to the image and recreate this with my origin being at the top of that green one. Okay, so by this point, again, if you're doing this exam, I would expect you know how to use the basic mates required already. So let's go through the process. I'm going to mate my top plane will be to that face. And then if I look at the long pin, my origin, where's its origin? Oh, its origin is there. So I can actually use those 2 to mate and align, and that part is fully defined. Okay. So then let's grab one of our pins in and get those mated, one of these in. Now it has X, Y, and Z, and X in this case is my front plane. So I want that to be in line with this face. So they're parallel, and that makes this chain link part fully defined. My short pin is underdefined, but that's just the rotation. I can lock the rotation, and then all those 3 are fully defined. Let's save, just in case, sample exam assembly. And now from here, I'm just going to duplicate the parts I need. So I'm going to get another one of these. I'm only going to add them as I go. So I'm going to make those two. And I don't know if there's a gap between these or not. It looks like not. So I can do coincident. That's asked to mate an angle. So angle A is 25. Well, in this example, I'm not going to do global variables. I'm just going to get the angles in there. So I'm going to select this top face and this face. I'm going to select angle. Now I can see the number here it's giving me 152. If I put in 25, it's going to flip it, right? Don't want that. So undo, try again with the angle, but type in 180 minus 25. Then you'll get the correct dimension you actually need. Okay, so I've got that one. Let's just get the other yellow parts in. So I'm going to get one of these here. And this is going to have an angle B of 125. So that's from this face to this face. Now this one does work. Okay, so I can put the exact number in. And then I want to get another one of these. So I'm going to go, I'll put one of those in. Now putting the pins in is important because it wants the center of gravity. And if you're missing some parts, you're not going to get the correct center of gravity. I think the last one is this one. That I think I've got my angles correct. The last one is C. C is 130. So this face, and this face, angle 130. Okay, done. Finish off my assembly with these two parts and just make sure everything's fully defined. This short pin needs a lock rotation. If I go isometric view, this is the view they're using in the drawing. Okay, so that's good. Save, units, millimeters, it's correct. All my parts are there. The question, what is the center of the mass of the assembly? Let's go to evaluate. Let's go to mass properties. And we're looking here for the center of the mass, which is 348.66 minus 88.48 and minus 91.4. And that all aligns with answer A. Answer 1 is A, right? So we've got that checked. Now we need to modify the assembly. And the only thing we're modifying are the dimensions of the angles. And if we look in our mates folder, we should see that there's only 3 angles in there. Angle A changes from 25 to 30 degrees. Now we did 180 minus 25. Now we want to minus another 5. So this should be 150. So we're going to type that in and that'll update. Angle B went from 125 to 115. Click, type, enter. C, 130 to 135. Click, type, enter. What is the center of mass? And we'll go mass properties. Let's click mass properties, center of mass. Now 327.98 and 102. And you're done. Let's check our answers. So on model 1, answer 2. Now we've got the answers here on the answer key. We knew already we're doing a crop view and a broken out section view. Easy. Question 3. Answer was D, 939.54. All right. Question 4, that's the first one that we listed as a comment. We can see here in the comment, answer 2, which is actually answer number 4, 1032.32 is correct. Our next answer, answer 3, we wrote down 628.18 is correct. And then our last answer for our mass, 432.58, that is also correct. So all 3 of those calculation answers where you're not giving a multiple selection choice, you have to actually come up with the answer. We've got those spot on. And then if we go into our assembly, we know that answer A was our first selection. And for the very last question, our mass, if we've done all of those changes correctly, center of gravity, center of mass is 327 minus 98 minus 102. And that is the end of the assembly walkthrough. Now, we have flown through that. Okay, we've done that in under an hour. Granted, I'm moving very quick given my experience with mouse gestures, sketching, dimensions, and global variables. However, if you were to get a similar question by following those steps in your sketching, okay, you're fully defining, and then being very meticulous about the selections of the dimensions you're changing, and checking, like we did on these questions here, particularly Like here, when you're given multiple views of an object, okay, we checked underneath and we go, hey, we haven't done that cutout. It's those things that are going to help you to set your answers to the exams and the practice exams. So look, I really hope you enjoyed that. I'm going to link below for those that aren't super confident yet with their sketching skills, a couple of the other SolidWorks tutorials that I've done walkthroughs on. That includes sketching, that includes fillets, that includes assembly mates. Also linked in the description will be some of the other projects I've shown, which teach these skills from a beginner level. If you are someone that is looking to do your CSWA and you feel like you need more training or more resources, please leave a comment below. Let me know what you're missing, or let me know what you need, and I'll work on getting that for you. Okay. So thanks very much for tuning in. Hope you enjoyed this episode of Fully Defined. Good luck. I'll see you in the next one. Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.